Good morning, this is your Stats Sensei, Mr. Spensei, and this is part of the test review, and it'll be problems 2 and 3 on running simulations. So the question for number 2 is explain how to run a simulation using the Halloween holiday. And what it doesn't say, but we need to know, as the probability of a trick is 50%, and the probability of a treat is 50%. So in both cases, the probability of trick and probability of treat are equal or one half. So in this case, I'm going to sit there and go, well, I'm going to make my number line like I like to do. And I'm going to go, well, my number line is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0. And half of those will be tricks and half of those will be treats. So we need to go through this. And the success will be getting a treat. Obviously, the question is, will you get a trick or treat? We're going to call a success getting a treat, and we're going to run 5 trials. We're going to run 5 trials. Okay. So because we're dealing with percentages, 50%, duplicates are not an issue. So duplicates would be permitted. All right. So we're going to choose 1-digit numbers because they're much faster to work with. And we're going to say that a treat are numbers 1 through 5. That's half of it. And then 6, 7, 8, 9, and 0 will be tricks. Once again, we need 50% or half of the numbers to be treats. And we're going to assign them 1 to 5. And there will be the rest of them will be tricks. And in this situation, we have no skips. So when we're always running them, we're beginning from left to right, just the way we read. I would select 1-digit numbers until I have 5 treats. So a specific trial says, hey, we're going to have to get 5 treats. That's the way we're defining a success. We're going to count the number of 1-digit numbers until we got 5 treats. So you're going to just keep going and going until we get 5 successes or 5 treats. And then we're going to repeat this and run 10 trials and take the average number of houses visited to get 5 treats on average. So what we'd be saying is in the long run, on average, we had to visit this number of houses in order to get 5 treats. We weren't going to worry about the number of tricks. We we're going to keep track of the number of treats. Those would be successes. 6 through 9 and 0 are tricks, and there would be no skips. All right. The next question. If a family has 4 children, what's the probability that all 4 children are girls? Run 5 trials. Once again, we're going to go with the idea that there's 50% of children are boys and 50% are girls. So we're going to go ahead and make a number line, and we're going to go, and we wanted to know the probability of girls. So when we have our number line 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0, we're going to assign 1 through 5 as girls. That's going to be a success. And the rest will be boys. So 6, 7, 8, 9, and 0. So we'll go ahead and we're going to say, all right, here's our assignment, girls 1 through 5, boys 6 through 9, and 0. And we're going to have no skips because we're going to use every single one of the 1-digit numbers. We could have used 2-digit numbers, but it would have taken a lot longer to run. So in this case, when we look at this, we go, well, 7. 7 happens to be a boy. 1 is a girl, 3 is a girl. Oh, one other thing. Repeats are allowed. Why are repeats allowed? Repeats are allowed because we're working with percentages. Now, that wasn't asked in the question, but you need to keep that in mind for when we run this. So, repeats are permitted. All right? So, if we have any repeats, we don't have to worry about it. So, We go 1, 2, 3, 4, and we're going to stop once we have um, four children. So in this case, we have four children after we have five numbers. And by the way, I mean, four numbers. We'll always have four numbers every single time. So 1, 2, 3, 4. And I look at those four numbers and I go, well, girl, because it's a one, and that's in a girl category. Three is a girl, two is a girl. So in this case, we had three girls and one boy. That was trial one. I'll put a one for trial one. And then the next one, we count out four numbers: 1, 2, 3, 4. So 1, 2, 3, 4. And we could have started, if we wanted to, we could have started here, but we'd all get different answers. But by now, you know that when you run simulations, you can get different answers. So they started here at 5. That 5 is a girl, 5 is a girl, 5 is a girl, and 2 is a girl because 1 through 5. So we ended up getting four girls. The next one, we had a 1. This is a boy. Number 7 here is a boy. 1, 3, and we ended up with three girls. Don't know if y'all can see that. The first trial had three girls. The second trial had four girls. The next one had three girls out of the four. And then the next one we had 1, 2, or 1, 2, 3, 4 numbers. Those are four numbers. But of those numbers, we had a 0 and a 7. The 0 is a boy, and the 7 is a boy. So in this case, we had two girls, and we recorded that on the table. And on the last one, we go 1, 2, 3, 4 numbers. That represents the four children. And we have a 2, that's the girl. And then the rest of these are boys. So we ended up with, in trial 5, we ended up with one girl out of the four children. So the question was calculate the probability of that all four are girls. Well, when I look at this, all four that were girls happened one time. I needed a 4. So that was one time out of 5. So 1 out of 5 equals 20%. For those of you who struggle with percents, 1 out of 5 equals x over 100. That does not look like an x. Apologize for that. You're going to multiply the two numbers on the diagonal. So 1 times 100 divided by 5. And when you do that, you're going to end up with 100 over 5 equals 20%. All right. So in this case, 20% chance that a family of four would have all girls based on our simulation. All right. So based on our simulation, that's what we'd expect. All right. I hope you enjoyed this. Hope it helped, and good luck on your test. Thank you.